Alright, continuing on with the factoring of trigonometric expressions, we run into a little bit of a problem here on this because we don't have the same expression being used. In other words, they're not both cosecant on this. I've got one cosecant squared and I've got one cotangent. And so I need to find a way to get both of these to be the exact same thing. So I need to call on one of my trigonometric identities here. I think the easiest thing to do would be to convert this cosecant squared into something else. And so the one that I have memorized, I don't have all these identities memorized, but I do know that sine squared x plus cosine squared x is equal to 1. And so if I really want to turn that into a cosecant, I know that that's really 1 over the sine, right? That's 1 over the sine. So how can I get 1 over sine squared in this expression? Well, I think the easiest way to do that would be to divide every single term here by sine squared of x, because if I do that, I see on the right hand side of this I have 1 over sine squared. That would be cosecant squared. Over here I have cosine over sine. That would be cotangent, and since everything's squared, I can say that's cotangent squared x. And the first term I have sine over sine. Well, that's just 1. So I know that cosecant squared is the same thing as 1 plus cotangent squared. I'm going to go ahead, I'm going to take this information right here, I'm going to substitute it in for that cosecant squared. And the expression now becomes 1 plus the cotangent squared of x minus the cotangent of x minus 3. So I got a new expression here, and notice everything involves cotangent, which is good. So I'm going to rearrange this. I want to put it in order from highest power of cotangent, so cotangent squared first, then the minus cotangent x, and I need to combine like terms. I've got a -1 and a +3, that would be -2. I put them in order from square, first power of x, or first power of cotangent, excuse me, and then 0 power. So now I'm ready to solve. I can do that u substitution thing I talked about in the last video. Let's let u equal the cotangent of x. That makes this expression u squared minus u minus 2. And I go through and I'm like, you know what? I can factor that one. That would be u minus 2, u plus 1, right? Which means that now I can go back and replace the u with the cotangent that I knew that it was. My final answer is going to be the cotangent of x minus 2, the cotangent of x plus 1. And I've got a factored expression to use. Over here, same idea, except this time it's involving secants and tangents. And so I'm going to come over here first. I know that sine squared x plus cosine squared of x is equal to 1. I need to get a secant squared out of this, and secant I know is 1 over the cosine. So that means that I better take this 1 here. Let's divide every single term by cosine squared. Because if I do that, now on the right side of the equation I have 1 over cosine squared. There's my secant squared that I was looking for. And I can tell you that that is equal to, let's see, that's cosine over cosine. That would be 1. And I have sine over cosine, which is the same thing as tangent. And since it's squared, we can say tangent squared of x plus 1 is equal to secant squared. So now, knowing that, I'm going to take this tangent x squared plus 1, I'm going to substitute it in right here for that secant squared, because now everything will be in terms of tangent. So I have tangent x squared x, I don't know why I put parentheses there, ignore them, plus 1. There's where I wanted the parentheses, so sorry about that. X that out. Tangent of x squared of x plus 1 plus 3 times the tangent of x plus 1. There's my overall expression now. So I'm going to reorder these and combine like terms, combine these ones here. Looks like that I have tangent squared of x plus 3 tangent x plus 2. So if I want to use u substitution, it looks like u would be the tangent of x. So I really have u squared plus 3u plus 2. And I know that I can factor that. That would be u plus 2, u plus 1. So that means my final answer must be, instead of u, it's going to be tangent of x plus 2, tangent of x plus 1. And that gives us something useful that we can use later on to solve for x.